we need to consider selectivity when we're looking at organic synthesis. We've already looked at a lot of reactions that have selectivity. And so I'm just going to review some and discuss as we go along. So to begin, we'll go back quite a while to when we were talking about SN2 and E2 reactions. And we'll consider one of those. So I'll pick something that has a good leaving group, like this tosylate. And if we treat it with something that's a good nucleophile, like this cyanide, then we will have a substitution reaction, and it will be selective towards that. This is an SN2. Alternatively, we could select for a reduction reaction using different reagents, like sodium T-butoxide. And now we've selected for E2, plus the other reagents, leaving group and the alcohol. E2 selectivity. So in this case, we've chosen either a strong nucleophile that comes in, does a selective nucleophilic attack, or we've picked a good base that then selects for E2 or elimination. Other selective reactions that we've discussed are alpha addition. So just review that. So here we have a choice, right? There is a hydrogen on this location, and there are several over here. And if you recall, if we employ kinetic conditions and do this with lithium diisopropylamide, or LDA, at low temperature, minus, 50. And then add in our other substrate, methyl iodide. Then we will get the kinetic product, and that is a selective reaction. We're selecting for the less substituted side by using kinetic conditions. So alpha addition, and this is the kinetic selection. And of course, as a review, we can employ thermodynamic conditions by choosing a much weaker base than LDA. It's still a strong base, but it's not compared to LDA. And we'll need to run this at a higher temperature, say 40 degrees C. Same substrate here. And now we've selected for the other side. Alpha addition, thermodynamic. Now let's look at direct versus conjugate addition as another example of a selective reaction that we've looked at. So this could undergo either direct addition or conjugate addition, depending on the conditions that we choose. So if we employ either a Grignard or the organolithium reagent, then we'll do direct addition selectively. need some diethyl ether, and then of course we'll need our acid workup step. And then in this case, we will have done direct addition. And it is selective towards that. So 1, 2. We could change our conditions by using the cuprate. And then this would select for conjugate addition. Still need our acid workup step. So these are some of the selective reactions. I'm going to include one more, which is epoxide openings. And recall that we can choose which side we're opening based on whether we're operating under acidic or basic conditions. So first, if we open this under basic conditions, let's say we are using an alkoxide. That's definitely basic conditions. And then to acid just for the workup. Then we will open on the least substituted side. So as a refresher, should get this. So running it under basic conditions, whereas if instead we chose to run it under acidic conditions, then we would open in the other direction. And we would have substitution on the more substituted carbon, since that is favored in this case. So these are some of the reactions that we have discussed that employ selectivity, either in what kind of reaction we're doing or the location at which the substitution occurs. There are more reactions that exhibit selectivity. This is just a portion of them. It's not really possible to discuss every selective reaction out there. But this is another thing that we are going to consider when we're doing organic synthesis.